Welcome to Practicon. Today in this video, let's discuss about member orientation, generally called as a beta angle for the steel structures. The beta angle has to do with the member orientation in space 3D structures. Aligning these members with respect to the force will always provide the best optimized member capacities, member utilizations. Basically, this member orientation is also associated with strong and weak axis bending. So we should not ignore it when working with the sections like I sections, channel sections, T sections, or unequal angle sections. So first actually what we can do, we discuss about what is this orientation, and by doing so, like rotating these members, how the section properties actually will impact and how this impact will be considered in the member design and analysis as well. Generally, if you see, nowadays most of us, we use a structural software like STAAD Pro for analysis and design of steel structures. It automatically does the force calculations, like a wind load generations and member design, everything. But being an engineer, what we have to do, like aligning these members oriented in the direction of the force or in the direction of the exposed areas, will be the critical for the steel design. So just a simple concept over here, when you do the member orientation, let's say in STAAD Pro, so we call it as a beta angle. The beta 0 is by default the section will be in the below picture. If you make it as a beta 30, it will be in the above picture, rotating 90%, right? So let's say if you have a column or maybe the beam members or the bracing members, when you want to orient those sections with respect to 0 degrees or 45 degrees or 90 degrees, you can use this beta angle to orient in that direction. When you do this change, the members oriented with respect to the forces, how the STAAD engine will consider this. The section properties you see over here, we are calculating the depth in the direction of the Y and the width in the direction of the X. If you over here, when you look at the orientation of the both, even if you go to the before picture, this one, the Y-axis is actually along the depth of the section. When even you rotate with the 90 degrees, still the Y-axis is along the depth of the section. That means your sectional properties are remain same even if you rotate with respect to the local axis. But however, the STAAD actually will consider these section properties with respect to the local axis, but the stiffness will be adjusted according to the global axis. When it has been analyzed, the bending moments will vary based on the orientation. For example, in this direction, when the beta angle is 0, the bending moment is 10 kilonewton meter for particularly this example. The same thing if you go to the member has been oriented in horizontal direction, the bending moment My is 10, here Mz is 10. Section properties are remain same. At the same time, the bending stress over here Mz by Iz, over here the bending stress is My by Iy. So the stresses is nothing but the utilization ratio will be considered according to the, again it's a local axis, right? So you will be getting the program automatically will do all the internal calculations based on the orientation and the global stiffness, and finally we will get the analysis forces with respect to the direction of the orientation that we have oriented, and the design will be doing automatically. So what actually we need to be careful, we need to orient the sections as required, and the remaining part will be done by the program automatically. Thank you very much. If you have more questions, please give a comment section. We'll be happy to reply on that. if there is a more details, you can please refer to the STAAD help manual. Thank you very much.